Chapter 3, problem number 24. A major league pitcher can throw a baseball in excess of 41 meters per second. If a ball is thrown horizontally at this speed, how much will it drop by the time it reaches a catcher who is 17 meters away from the point of release? So he's throwing the ball at 41 meters per second, and that's in the horizontal direction. The original velocity in the y is 0 meters per second. And they want to know if the ball travels 17 meters horizontally, how much will it drop? So we're looking for delta y. Now it's accelerating, and let me put that first, at negative 10 meters per second squared. So let me draw a sketch of this. Okay, so here's the ball traveling at Vx, and we're supposed to figure out delta y when it has traveled horizontally at 17 meters, and of course accelerating downward at negative 10 meters per second squared. So I'm going to start with an equation for delta y. So we have delta y is equal to original velocity in the y times time, which of course goes to 0, that term, plus 1/2 the acceleration times the time squared. Well, in order to find delta y, we need time. So I'm thinking here maybe a different equation we can use. How about delta y is equal to the original velocity in the y plus the final velocity in the y over 2 multiplied by time? Well, to find delta y here, we would need to know VFY and time. Okay, so let's try another one. How about VFY squared? There's the same problem. So it looks like we're going to have to first find the time it takes the ball to travel 17 meters by looking at the horizontal motion. There we go. So and then once I know the time, I'll substitute it into here. Because you see, with the horizontal motion, we know enough information to find the time. So I'm going to get rid of this, and I get this equation first, which allows me to find delta y. And then I was figuring out how to get the time, and it took me a little while until I realized, oh, let's look at the horizontal motion. So here we go. Vx is equal to delta x over delta t, right? We know the horizontal displacement, and we know the velocity in the x. So I solve this for time, and we get displacement in the x over the velocity in the x, and I'm going to substitute this into this expression here. Okay, and I'll do that over here. So we have the displacement in the y is equal to 1/2 the acceleration due to gravity times the displacement in the x squared over the velocity in the x squared. Doing the numbers, we have 1/2 times negative 10 meters per second squared multiplied by 17 meters squared over 41 meters per second squared. So let's see what we get for the vertical displacement. 17 squared, 41 squared. Going to take the reciprocal of 41 squared and then multiply it by 17 squared. And I'm going to multiply that by half of negative 10, negative 5. And I get negative 0.86 meters. Okay, so the ball falls negative 0.86 meters. Okay, so that means it falls downward.